Linear inequalities. Let's start by solving this inequality. We will first subtract 5x both sides so that the x's will be on one side. 3x minus 5x will give you negative 2x, right? And then we will add to both sides so that 2 will be cancelled and you just have negative 2x only on the left side, whereas 4 plus 2 gives you 6. Okay. Then because I want to isolate x, see, solving inequalities is pretty much the same thing as solving equalities when it comes to linear. If you try to solve quadratic or other more complicated ones, then there's a whole different procedure for doing it. But when it comes to solving linear ones, you pretty much do exactly the same thing as you solve equalities. Except there's one place that you have to be careful, is that if you divide by a negative number, then instead of having negative 2 divided by negative 2 will cancel and you just have x. 6 divided by negative 2 is, if you divide positive by negative, it's negative. So, and 6 divided by 2 is negative 3, right? And the important thing is if you divide by negative, the inequality sign has to flip. Okay, so let's write that as a note. Note, when dividing or multiplying by a negative number, flip the inequality sign. Okay? Alright. Let's now work with this next inequality. Let's see. I will multiply the 4, so it'll be 4x minus 8 less or equals to negative x plus 6. And I will add x both sides so that x is all on one side, and then I'll add 8 to both sides so that the numbers are on the other side. 4x plus x is 5x. Negative 8 plus 8 will be gone. Negative x plus x will be gone, and 6 plus 8 gives you 14. So this tells us that x must be less or equals to 14 over 5. Okay. So putting these two together, we can say that the answer is x has to be greater than negative 3, and also x has to be less or equals to 14 over 5. Yeah. I put and because the original question has this and there. Okay, so that's the answer. However, this is not a good way to write your answer. The better way is this. Since x has to be both bigger than negative 3 and less or equals to 14 over 5, you can write this into a single inequality, because whatever your x is, your x has to be less or equals to 14 over 5 and has to be bigger than negative 3. So this is the really nice way to say the answer. Okay, you should write the answer this way, not that way. Okay, now let's think about how to represent this solution. Negative 3 less than x less or equals to 14 over 3. The first method is using the number line. So you draw the number line. Let's say here's 0, and negative 3 will be left of negative 3 will be left of 0, right? Whereas 14 over 3, that's about 5. So let's just say here's 14 over 3. You don't have to be exact. Okay. Now then, your x has to be between these two numbers, so you should say that x is somewhere here. make a thick line here to represent the fact that x has to be between. And because it has this equal sign, 14 over 3 is included, right? To represent that, you use a circle that's circled in. And while negative 3 is not included, so in that case, you put an open circle. This one's called a closed circle. This is called an open circle. Open circle means it's not painted inside. It's just a blank circle, okay? So here, this one is called the closed circle because 14 over 3 is included, right? 14 over 3 is included, the equal sign. And over here, this one's called the open circle, and we use the open circle because negative 3 is not included. Okay? So that's how you use the number line to represent the solution. Now there's still another way to represent the solution, which is called the interval notation. And it's good to have this picture before you write the interval notation because it's kind of clear what this represents. See, your x should be between these two, so it has to be between negative 3 and 14 over 3. And you use a closed bracket for the case when that number, the endpoint is included, and you use an open bracket, a circular bracket, the usual parenthesis, that's called the open bracket. This one we call square bracket, but also known as a closed bracket. Okay, so if you have an open bracket and a closed bracket, that faithfully represents this picture. Okay, so let me say that this is open bracket, and this one right here is closed bracket. Okay, here I want to add another note. Sometimes people get confused, and when they see these two numbers, they're like, okay, it has to be between 14 over 3 and also negative 3, and people make this mistake. I mean, you think you would never make this mistake, but sometimes when you write your answer in haste, sometimes you forget things and you put this backwards. Now this is not good. This is wrong. Okay, you shouldn't do this, because the reason this is wrong is because 14 over 3 is bigger than negative 3. So when you have two numbers, two endpoints of an interval, then you should always have the smaller number should be on the left, okay, or else it's considered wrong. Okay, let's do the next question. Here we have an inequality that's that has fractions. Okay, and just like how we dealt with linear equations with fractions, I think the better idea is to multiply by the common denominator to get rid of the denominator. So let's multiply by 4, because multiplying by 4 will get rid of this, right? So I'm going to multiply 4 to the left side, and also I'm going to multiply 4 to the right side. 4 divided by 2, that's just 2. Now remember, when it's a multiplication, you don't distribute. 4 only gets multiplied to one of them, not both. So I can choose to multiply 4 to this one or that one, but I choose to multiply this one. And the reason I do that is because 4 divided by 2 is just simply 2. So it's a lot easier, okay? So be careful. Don't multiply to both, just multiply to one. And then when 4 is multiplied, 4 divided by 4 is 1, so you just get x, and 4 times 1 would be 4. Multiply them out, you get 2x plus 12. Subtract x both sides, and subtract 12 both sides. And we get that x has to be less or equal to 2x minus x is x, and 4 minus 12 is negative 8. So that's the answer to the first one. Let's do the second one. 4x minus 1 less than 6x minus 5. This time let's subtract 4x and add 5. So I'm moving the numbers to the left side and putting the x to the other side. Okay, negative 1 plus 5 is 4. 6x minus 4x is just 2x. And then if you divide by 2, you get 2 is less than x. Okay? And then you have to put these two together. So answer is, well, remember it has this or, okay? So it has this or. So if it has an or, then when you combine the two answers, you have to say x is less or equals to negative 8, or x is bigger than 2. Okay? And here you can't write it as a single inequality. You're just stuck with this. Okay? You can write it in a single line, but it still has to be two inequalities. Okay? So it's really saying that for a value of x to satisfy this, it either has to be less or equals to negative 8, in which case negative 9, negative 10, negative 100, all these are solutions. On the other hand, x bigger than 2 is a solution, so it could be 3, 4, 5. Okay? Alright, now let's try to write this answer in the two formats that we discussed. So first, you could use the number line, and here's negative 8, here's positive 2, so 0 should be somewhere here. You don't even have to put the 0. Negative 8 is left of 2. That's all. That's the only thing that's important. Okay, and I am going to color this side, right? And negative 8 is included, so you put a closed circle, and 2 is not included, but it could be bigger than 2, so this side is included. Okay, and this means, in terms of the interval notation, this means you have two intervals, one that begins from negative infinity and ends at negative 8. So the first interval is negative infinity and ends at negative 8. And negative 8 is included, so you use a closed bracket. When you have infinities or negative infinities, you never put closed bracket. It's always the circular bracket, the open bracket, because negative infinity and positive infinity are not numbers. So you can't say it includes. Okay, so you always put open interval like that. The other interval is, it starts from 2 and goes till infinity. So it skips the 2, but then it includes everything after 2, right? So I use open brackets for both. And here's the important thing. If you have more than one interval, you should put the u. Okay? So u is like a symbol. U is the symbol for the union. And it's a mathematical symbol for math symbol for or. Okay, so when you want to say x is less or equals to negative 8 and x greater than 2, then you can say it's the union of these two sets, and well, this is not I want to put this in quotes because it's not really exact. See, the trouble is, in order to really understand this union, we have to go into the set theory, but that's like another weeks of class, and I don't want to spend that much time just to think about why people use the union. You just have to remember that if you have more than one interval, then between each interval you have to put the u there. Okay. All right, absolute value inequalities. Let's think about this inequality. For what values does this get satisfied? So we know that this is true for x equals to, say, 5, right? Or 4. It could also be like -5 is also good. -3 or -4, it's all good. You can even do decimals, like 4.1 is okay, or -1.5, that's okay. So you have both positive and negatives, but this is not true for -6, right? -6 absolute value is what? That's +6, and +6 is actually bigger than 5. So it's not true for x equals to -6. Okay. So after just some observations, so let me just put this like that and just title this as observations. Okay. And after doing some of these observations, you should come up with the following conclusion, that this would be true when your x value is between 5 and -5. Okay? And that's actually very important. When you have absolute value of something lesser or equals to some a, say a, looks like a 9, a, then it becomes that something must be between a and -a. Okay? So that's an important way to solve absolute value inequalities. So let me demonstrate how you can use this property to solve this next inequality. So let's say you have x minus 2 absolute value less than 9. Then using this same analogy, we know that x minus 2 has to be between 9 and -9. Okay? And then you add 2 everywhere, which gives you -9 plus 2 is -7. 9 plus 2 is 11. So that's the answer. And in interval notation, this would be -7 comma 11. Okay? So there are two ways to write the answer. Sometimes your homework or the question might ask you for this type of answer, or they might ask you for the interval notation answer. Okay. What about inequalities with absolute value where absolute value is bigger than a number? Well, again, let's make some observations. So, observations. Does x equals to 4 work? Yes. How about x equals to 5, 6, 7? That's all good. But also x equals to -4 works and -5 works. Okay. But x equals to -6 doesn't work. This one doesn't work. Okay. So actually, I got it backwards, right? So this should have been -6, -7. Those are okay, right? -6 absolute value is what? +6, which is bigger than 4, right? -7 is good. However, -3 is a no. Absolute value of -3 is +3. 3 is not bigger than +4. Okay. All right, so we see that x could be 4 or bigger, and x could be -4 or less. -4 is good, -5 is good. So after these observations, you can conclude that either x is greater or equal to 4, or x is lesser equal to -4. Okay, so if you have absolute value bigger than a, then it's greater than the positive, or it's less than the negative. Okay, so maybe I could summarize it. If you have something greater than a, that would mean that something is greater or equals to 4, or not 4, a, or something is less or equals to -a. Okay. All right. So let's use that same idea. Here we have an absolute value bigger than 3, so that means 1/2 of x minus 3 is greater than 3, or 1/2 x minus 3 is less than negative of 3. Okay, so greater than the positive, less than the negative. Now notice how because this doesn't have an equal sign, I didn't put the equal sign. Okay, if it has an equal sign, you put the equal sign, but here, because it doesn't have the equal sign with it, equal sign shouldn't be there. Okay, now let's just solve these two separately. So if I add 3 both sides, 1/2 x would be bigger than 3 plus 3, which is 6, and then I multiply by 2, so x would be greater than 6 times 2, which is 12. Over here, if I add 3 both sides, well, that's a 0, right? So 1/2 x is less than 0, and if I multiply by 2, x is simply less than 0. Okay, and because it has an or, this should be an or. And in terms of the number line, here's 0, here's 12, and either x is greater than 12 or less than 0, and in both cases these are strict inequalities, so you have to put open circles. Okay, in terms of interval, the first interval is -infinity up till 0, but 0 is not included. The second interval is 12 until infinity, and 12 is not included, and because you have more than one interval, you must have a union. Okay, that's very important. Alright, so let's see how we can actually use this. The absolute value inequality, especially in the form of absolute value of something less than some number, is used to represent some errors. Okay, so this is the usual format. If you have some actual thing that you don't know exactly what it is, but you have some idea of what it could be, then often what's possible is, even though you don't know exactly what it is, you can still say that the absolute value between the two. Oh, by the way, if you have, maybe I should write somewhere here, a minus b absolute value means distance from a to b. Okay, see, distance is always positive, so if you subtract, it kind of gives you the distance between the two numbers, except that sometimes it's negative, so that's why you want to put the absolute value. Okay, so often what happens is, when you have some actual value you have no idea of, and you have some idea of what it could be, although you don't know the actual value, you can say that the actual and your ideal approximation or some average or whatever should be less than, their distance should be less than some tolerance. Okay, that's the way people write. Okay, and this ideal could be something that you think the actual should be. Like, it could be some measurement of the actual, so you don't know what this length is, but you use the ruler and you kind of have an idea of what that length is, but you know, rulers are never exact, so it might have some error, right? Your measurement will have some kind of an error, right? Or if you have several values and you know the average of them, then you can think of the ideal as that average or the approximation or whatever, okay? Total tolerance is the maximum possible error, okay? The maximum possible distance between the ideal and the actual, or it could be some variance. You can say, I shouldn't say variance because that's a statistics word, but it can, so this means the difference between the actual and the ideal can be as big as some value, okay? Alright, so here's a word problem using such a thing. So Greg's Pizzeria delivers 112 pizza per day on average, but it can vary as much as 43, okay? So what this means is that on any day, let's say X is the number of pizza delivered, pizza pies delivered, okay, and on one day, okay, on one day, and X minus on the average is about 112. So the value of the actual delivery of pizza pies should be about the same as 112. It could be, there could be some difference, but it says it can vary as much as 43. So the difference of this could be as much as 43. Okay. So that's how you represent this as an absolute value inequality, and you can actually solve this by first saying that this should be between the positive of this number and the negative of this number, and then you can add a 112 both sides, which is let's see, if you subtract 3, it's 109. 109 minus 40 would be 69. Okay, so this would be 69. It'll be X, and this would be 155. Okay, so that's the answer, and you can say max would be 155 pizza pies. In word problems, it's good to always put the units, okay? And then min would be 69 pizza pies.